Hey guys, welcome back. So in this video we're going to examine how generic classes work and why the array list works like this. The way we're going to do this is actually pretty cool. We're going to implement or we're going to create an array list class ourselves. So let's do this. Let's create our own array list and we'll call it maybe something like Oracle array list. So we're going to create an Oracle array list class. And what we're going to do is let's examine what it would look like without a generic interface. If we did this, then we would say maybe like private string items. So let's say, for example, that this array list, it only worked with strings. If it only worked with strings, then we could have something like this, Oracle array list. We have our default constructor, and let's just not do anything inside of it right now. And we have this method called add item, so we're going to add a string. And the way we're going to do this is, okay, so first let's actually initialize our string array to contain a minimum of 10 items. So it's going to contain 10 items, and then we basically need to keep count of how many of those items have already been filled. Filled spots. And just to keep the naming consistent, I'm going to call this items. So filled spots, it's going to start at 0, and what we're going to do is we're going to check to see if the number of items that we've already put into the array, if it's less than items.length. So for example, 0, when we start out, 0 is less than 10. That's the length of our array. So we can put something inside of there, inside of our items array. So then we can just say items at filled spots is equal to item, and then we're just going to increment filled spots by 1. So we're going to say items, and remember filled spots, it starts at 0, right? So we're going to put this item at index 0 inside of our array, and then we're going to increment the next spot we can put our basically our items into. So then when the next time we call this, we're going to do items at 1 is equal to this other item, and then we'll increment it again, and so we'll populate our array this way. However, we run into the case, for example, when we add more than 10 items. When we add more than 10 items, what we need to do is we need to resize our array. So for example, if we might make our array 20 items long. The thing is, we have to make sure that the first 10 blocks of memory have their original values. We don't want to erase any values, right? So the way we're going to do this is we're first going to create a copy of our item, so we have our original 10 blocks. Then what we're going to do is we're just going to do items is equal to new string. And now we're going to do this. We're going to get the current size, right? So it might be 10, it might be 20, and then we're just going to add 10. So we're going to add 10 more blocks of memory. Then what we're going to do is, let's see here, so we want to add an item, right? So what we need to do is now we need to copy over the old values. So old values inside copy is actually, let's use the original for syntax like this, and then what we're going to do is we're just going to say items at I is equal to copy at I. Okay, and now finally we need to actually add the item. So let's use a little bit of recursion here, and let's just add the item. And this will work because now that we've resized our array and we go up here, we call add again, what we're going to do is, well, filled spot is now going to be less than the length of our array because the length of our array is 10 longer this time, and so we're going to go inside this guy right here. So this is kind of an elegant solution, actually. Alright, now that we've done that, let's create a method called get, and this get function, remember we have to do this because this items array, it's private, and because it's private, that means if you're outside of this Oracle array list class, you can't actually access this array directly, and so you can't access every item using, for example, this subscript notation like items at 10. So all we're going to do is we're just going to return items at index. If index is larger than the size of our array, or if it's less than 0, then our program is going to crash. And this is the behavior we want, because we want programs to crash when they try to access memory that's outside of like the balance they've allocated. Okay, so let's test this out now. What we're going to do is let's create an Oracle array list class. List is equal to new Oracle array list class. And then what we're going to do is we're just going to do list.add, and let's add item 1. Or actually, yeah, let's do it like this. We can be lazy and maybe go through 30 blocks of memory, and then what we're just going to do is we're just going to do list.add, and then toString I, and then all we're going to do is we're going to loop through our list. And I guess we can't use this for each syntax right now, but we're just going to loop through. Okay, we need one more method. We need a size method. Get size, public int size, and all we're going to do is items.length. Okay, and now we can just do list.size, and then we're just going to do system.out println list.get I. We run, and it works. So we have 0, 1, 2, 3, blah blah blah, and notice that we only allocated 10 blocks for strings, yet we're able to store 30 items, which indicates that our add functionality works. Whether it works well, that might be up for debate, because if we keep adding so many items, maybe we should allocate 100 blocks of memory, for example, so that we only have to copy it once. The problem is, so that we only have to reallocate it once or twice. The problem is, in that approach, you might be consuming too much memory. But for our cases, I mean, we can just say that, okay, this works sufficiently well. Okay, now, suppose we tried to do this. Suppose we wanted our list to not just hold strings, but to hold integers. Well, now we're going to get a compiler error, because we can only put strings inside of our Oracle array list class. Now, this is annoying, because in order to create something that worked for integers, the only way we could solve this is maybe to create another class and then copy this exact functionality over, except replace each of these things, like strings, with ints. And then we would do something like this. And then finally we would go over here and we would replace it with an integer. And we would have another class that would maybe look like Oracle list int. But this is a very bad approach, because it goes against the fundamental. There's a fundamental principle that you shouldn't ever have redundant code. Like, if we did that, we would have two sections of code that did the exact same thing, except this string would be replaced with every instance of string would basically just be replaced with an integer. And we don't want to do that. So this is where generic classes become very useful. What we can do is we can specify that this Oracle array list class, it works with any type. It works with any type specified inside of these little angry brackets. Then what we can do is we can replace every instance of, for example, string in this case, with the type that we're passing in over here. So, why are we getting a compiler error here? Cannot create an array. Okay, so we're getting a compiler error here, and this is actually perhaps something very counterintuitive, but for now, we're just going to kind of ignore it and use a little bit of hacks. What we're going to do is we're going to create an object array, and we're going to do this. In essence, kind of just ignore this line for now. Now what we're going to do is every time we see a string, we're just going to replace it with t. Like, all of this behavior, No, and we have to do the same thing here actually. New object. Alright, and one more time down here. Okay, so now let's test this out really quickly. Now when we want to specify a string, we put it inside these angler brackets. And we can just do integer.toString I. We run, and it'll work. We can also specify integers now. And when we want to specify integers, we can just pass in I right there, and it'll also work. We can put in doubles and so on. So now this code is a lot more clean. It's much more clean. Why? Because we've basically generified our code. We've made it so that instead of referring to string or integer or double inside here, we just replaced it with any arbitrary object. This t, in essence, can be replaced with any kind of item. It can be replaced with double. It can be replaced with integer, it can be replaced with string, and so on and so forth. And why do we want to do that? Well, the thing is, the behavior is the same for any kind of object, any kind of type. Okay, so now you're wondering why we're getting these compiler errors. The way it works is you can't actually create a generic, you can't do this, ut. Let's see here. You can't do this just because of some weird rules about Java, just some weird rules that Java implements. You can't actually create an array of generic types. If you want to do it, you have to use this really strange syntax where you create an object array and then cast it to your type, basically. Honestly, you don't have to worry about that too much. It was just we needed to do it in our example. In the next few videos, we're going to go over hash maps and tree sets, and dequeues, all good stuff. Alright, I'll see you guys then.